So in this podcast, what I want to do is to talk about an algebraic error which I think everybody who teaches mathematics has seen done by somebody at some stage. And somebody writes 1 over a plus b is 1 over a plus 1 over b. And what I want to do is just to argue why it's wrong in two different ways. So the first thing to notice is that if we're writing the right-hand side like this, obviously a and b cannot be 0 because we're not supposed to divide by 0, we'd have something ill-defined. And also, looking over here, we can't have a is equal to minus b because again we'd be dividing by 0. So I'm going to be making that assumption, and I'm also, if you know complex numbers, going to be assuming that a and b are real. So a and b are real. So the first and simplest way of seeing that this is not a correct algebraic identity is to say the following. Just substitute some values. So in the interests of simplicity, I'm just going to say a is equal to 1, and I'm going to say let b is equal to 1, and then what we see is that we have 1 over 1 plus 1, so 1 over 2 here, and then here we'd have 1 divided by 1, which is 1, plus 1 divided by 1, which is 1 again, so we would have 1 plus 1, which is 2. And obviously this is wrong, and this proves immediately that this identity is wrong for some values of a and b. It is perhaps possible that it would work for some values, and what one can see for complex numbers is that there are some solutions, but for real values there are no solutions, and that's what I want to show on the rest of the podcast. But already, just the fact that there are some values for which it works shows that this is not a good algebraic identity. And what we've done in a sense is proof by contradiction. We've assumed something is true and we've shown that it's not true, so therefore we have proven that saying 1 over a plus b is not 1 over a plus 1 over b is true. So this is clearly incorrect. So the other approach that I want to take to looking at this is to take an algebraic approach. So I want to use algebra, and I want to show that it doesn't work for any real a and b. So we look at this assumed identity, and we have 1 over a plus b is equal to, and now we have two fractions being added together here. So I'm going to put them on a common denominator, which is a times b. And 1 over a is b over ab. You can see that the b's would cancel. You'd have 1 over a left. And in a similar way, you have plus a over ab. The a's cancel, and this would be the 1 over b. So now I'm going to multiply both sides by a times b. And remember, a and b are not 0, so that's fine. We're not multiplying by 0. And I'm going to multiply by a plus b, and again, a is not minus b, so this is again safe. So what we obtain if we do this, multiplying by ab and also by a plus b, is on the left-hand side ab, and on the right-hand side we're going to have a plus b times b plus a, and b plus a is the same as a plus b, so we're going to get a plus b all squared. And this is something that we're going to use for the rest of this short podcast. And what I want to do is to show that writing this in this way is inconsistent, and therefore there are no solutions for real a and b. So let's just do that. So first of all, we notice if a and b have different signs, so one is positive and one is negative, I don't know which and I don't care, then what we would have here is something negative because it's positive times a negative, but here this is squared, so it's going to be positive. The smallest it could be would be 0, but that would only be if a was minus b, and we're not allowing that. So this side is positive, this side is negative, so we would have negative equals positive, and that is a contradiction. So that shows that there are no real values of a and b such that they have opposite signs and this identity could hold. What about if they have the same sign? So if a and b have the same sign, so they're both positive or they're both negative. Well, I'm going to go back to this relationship here, but I'm going to expand this. So what we have is AB is equal to, and now expanding a plus b squared gives us a squared plus the two cross terms, 2ab, plus b squared. So now, on this equation here, which is just this expanded out, I'm going to take the 2ab over to this side. So we have minus ab, because it's ab minus 2ab, is equal to a squared plus b squared. And again we see a contradiction. Remember, a and b have the same sign, and if they have the same sign, then this product is positive always, but there's a minus sign in front, so this side is going to be negative. But over here we have the sum of two squares, so this is positive. So what we conclude is, again, there is a contradiction, and we see that 1 over a plus b does not equal 1 over a plus 1 over b for any real a and b. So quickly, to go over it again, anybody who writes this out is making a mistake for real variables, and you can see this very easily just by substituting in some values. I've chosen here very simple numbers, but you could put in others, it doesn't matter, you'll see that this does not work. But algebraically we can also have this line of argument as well, and I think it's quite nice to see this sort of argument where you can see that if you make certain assumptions it leads to inconsistencies, and you see that in this particular case it's saying that something negative would have to be equal to something positive, and from that we can deduce that the original starting point was a mistake. And with that I'll stop.